This might surprise you. Depression has been studied surprisingly little using long-term brain imaging. Even advanced techniques like fMRI often rely on standardized brain maps, an approach that might work for a bone but not for the brain. The brain isn't static. It changes every second based on what you learn, experience, and focus on. Your brain is unique to you, and that's exactly what a group of researchers worked on, and they delivered. In 2024, they conducted a study revealing a significant step forward in understanding depression. They demonstrated the potential for diagnosing it through a medical procedure rather than talking, and even predicted long before it happens. I'm Dr. Daniel, and welcome to the Brain Lab. Using precision functional mapping, researchers found that a specific brain network was markedly larger in people with depression, twice the normal size. Not only that, but this enlargement was detectable since childhood. This network, called the Salience Network, a combination of brain regions including nodes in amygdala, hypothalamus, thalamus, ventral striatum, and specific brain nuclei, with its cortical hubs located in anterior cingulate cortex and ventral anterior insular cortex. This network plays a key role in reward processing and determining what truly matters and what deserves attention: hunger, pain, social embarrassment, amusement, or humor. Of course, it works with cooperation with other brain systems. Think of it as your brain spotlight. It decides what you need to focus on, because simply you can't focus on everything. That wouldn't even make sense. Why would you focus on something like the color of the chair in a room full of people talking to you? But how does it know what's important to focus on? Well, that's a long discussion. However, emotions likely play a huge role. Predators are dangerous, so we fear them. Anything that even resembles a predator instantly activates our attention system. This shortcut helps us focus on what truly matters without getting overwhelmed by unnecessary details. And this doesn't just apply to fear, it applies to all emotions. Now imagine if this network has trouble assessing emotions properly. Wouldn't that align with what happens in depression? When nothing seems to matter anymore, when nothing has a meaning. On the left side, you can see the Salience network in a normal individual, and on the right is the enlargement of the Salience network in depression, which doesn't necessarily need to be a continuous piece. The team has also tried to train a machine learning model to distinguish individuals with depression from healthy people. And guess what? The model correctly identified 82.5% of depressed cases. That's a big deal because depression can be misdiagnosed. Its symptoms overlap with other mental health conditions, or even physical ones, like thyroid disorder or chronic pain. In addition to that, the way people express emotions varies. Having a low appetite or avoiding social interaction doesn't necessarily mean you're depressed. You might just be an introvert. Diagnosing depression in childhood is even harder, while the consequences can be devastating. That's where this study comes in. The learning model didn't just improve diagnosis, it also led to a huge discovery. Some children had the brain changes, but they weren't depressed yet. Why is that? Because these differences in the brain's Salience network can actually be inherited. And here's another mind-blowing part. This means brain imaging could predict the predisposition to depression before it even develops. The Salience network is shedding new light on depression, though we're still covering its full impact. As the research advances, it could lead to earlier detection and better treatment. If you found this interesting, hit like and subscribe for more. Thanks for watching.